So moving to the next question, question number 31. 3 blocks of masses 2 kg, 3 kg and 5 kg are connected to each other with light string and are then placed on a frictionless surface as shown in the figure. The system is pulled by a force F equals to how much, children? 10 newtons. So the force applied here on the complete system is 10 newtons. Now we are asked to find the tension T1 in the string. So in order to solve this, first of all, let us try to find the acceleration of the complete system. We know that the acceleration of the complete system is the net force acting upon the total mass of the system. So A is equals to, so what is the net force applied, children? 10 Newton upon the whole mass is 2 plus 3 plus 5, that is 10 kg. Okay, hence acceleration is found to be 1 meter per second square. Acceleration is found to be 1 meter per second square. This is the acceleration. Now you are asked to find the tension T1 in the string. So clearly if you observe that this tension is a form of force which is pulling these two blocks towards left side. That means this force equals to the net force tension T1 is equals to the total mass into acceleration of the system. So it's very clear that all this complete system is accelerating towards left side. Hence the value of tension T1 is equals to, because of this tension, the total mass that is being pulled aside is 5 plus 3. That is 3 kg plus 5 kg into that acceleration. Okay, so this T1 is equals to 8 into 1, or T1 is equals to 8 Newton. Hence option number 3, that is C, 8 newtons must be true. Well, moving to the next question, children. Question number 32. So 2 blocks are connected by strings. So these are the strings and these are the 2 blocks connected by the strings as shown in the diagram. The upper block is hung by another string. A force F applied on the upper string produces an acceleration of 2 meter per second square. So the acceleration that is produced is given as 2 meter per second square in the upward direction in both the blocks. If T and T dash are the tensions in the 2 parts of the string, then you are asked to find the value of the tensions. Okay, some small mistakes are there. Let us correct it later, children. So you are asked to find the tensions T as well as T dash. Okay, so before working out, we'll have some small corrections, children. So if you look back, this is a 4 kg mass. So separately it was given. This is a 4 kg mass. No doubts, its weight is acting downwards. Its weight is nothing but 4g, mg, mass into gravity, 4 into g downwards. The tension in the string T dash is acting upwards. So no doubt the body is accelerating upwards. So what is that, children? The body will be accelerating upwards. Is clear? For the second block, if you observe this, for this block, tension T dash is acting downwards, whereas the weight of the 2 kg mass is also acting downwards. That is, weight is 2g and tension is T dash. Whereas the upward tension acting here is T, not T dash, children. It must be T. Okay? Tension T acting upwards. So based on this, and here the acceleration, it is also acting upwards with 2 meter per second square. Acceleration itself is given as 2 meter per second square. So let us, based on this free body diagram, let us write the equations. For the first case, what we observe is, as it is accelerating upwards, upward force must be greater than the downward force. Hence, the equation can be written as, for the case 1, this is 1 and here it is be 2. For the case 1, if you observe, upward force, that is T dash, minus downward force, that is 4g, must be equals to mass into acceleration, that is 4 into acceleration A. This is your first equation. Now moving for the second case. For the case 2, if you observe, here also it is moving upwards. So upward force is greater than the downward force. Upward force is T minus the downward force. Two forces are acting. One is weight of the body, the other is tension in the body. So that means 2G plus T dash must be equals to this mass into acceleration, that is 2 into A. So these are the two equations based on the above figure we have wrote. So now let us try to simplify the same. Okay children? Well, first of all, based on the equation 1, let us try to find out the value of T dash. So from equation 1, what does this imply children? T dash must be equals to 4A plus 4G, or T dash can be written as 4A acceleration is given as 2 meter per second square, and G, let us take it as 9.8 meter per second square. So T dash will be equals to 8 plus 9.8 into 4 is 8 4s 32, 39.2 newtons. Hence T dash is equals to 8 plus 39.2 is something around 47.2 newtons. Hence the value of T dash is found to be how much children? 47.2 newtons. Is that all clear? Well, so in all the cases, T dash, only here we have the value of T dash as 47.2 newtons. Let us also try to find out the value of T and check it out whether option A is true or not. So substituting the value of T dash in the second equation, let us see what happens. From second equation, T can be written as this minus 2G plus T dash. If it is taken other side, it will become 2G plus T dash plus 2A. Or T can be written as 2 into 9.8 plus T dash, we have just found it as 47.2 plus 2 into acceleration was given as 2, so 2 into 2 is 4. Or T is equals to 19.6 plus 47.2 plus 4, or the value of T is found to be, so 6 and 2 you have 8, and here we have 9 and 7 is 16 and 4 is 22. 2 is carried, so here 4 5s 70.8 newtons. Hence the value of T is found to be 70.8 newtons and T dash is found to be 47.2 newtons. Hence no doubt option number A must be true. Okay children? Well, so children, moving to the next question. Question number 33. Three masses 15 kg, 10 kg and 5 kg are suspended vertically as shown in the figure. If the string attached to the support, so here is your support children. So what is given? So here it is your support. So what it was given is the string attached to the support breaks. So this is the string attached to the support and given that this will break. So how means, okay, yes. So if the string attached to the support breaks, then what happens? The system falls freely. So the complete, whenever the string breaks here, the complete system will falls downwards. So whenever it falls downwards, then the acceleration of the system is given by A is equals to G. It falls freely. Freely falling body, acceleration is nothing but acceleration due to gravity. So A is taken as G. That's it. So what will be the tension in the string between 10 kg and 5 kg masses? So this is your 10 kg and this is your 5 kg. You're asked to find the tension between the two strings. So children, it's given that it is an example of a freely falling body and it is falling downwards, so accelerating downwards with an acceleration with the value of G. But we know that in order to find the tension in the string, we know that whenever it is falling downwards, moving downwards, tension is written as M into G minus A. Upward is given as M into G plus A, and downward motion it is given as mg minus M or M into G minus A. So know this. Hence T is equals to, so mass, whatever the total mass it is been falling, we'll take the total mass into, so G minus, so as it is a freely falling body, we know that the acceleration A is taken as G, so A is also replaced with G, so G minus G is 0, so 0 into anything is 0, hence the tension acting in the string is 0. So option number D must be true. Clear? Well, now moving to the next question. A light string passing over a smooth light pulley connects two blocks. How many blocks, children? Two blocks. One mass is m1, the other mass is m2. If the acceleration of the system is g by 8, then the ratio of the masses is, you're asked to find the ratio of masses. So for this, let us first of all imagine a system with connected with a pulley, and over the smooth frictionless pulley a string is being passing, okay, to which masses are being attached. Let us suppose that one mass is m1 and other mass is m2. Let us also assume that the mass m1 be greater than m2. So let us assume that the mass m1 is greater than m2. So no doubt the weight of m1 is acting downwards as m1g, and the tension in the string is T upwards. Here also m2g downwards, whereas the tension in the string same, that is T upwards. So if you observe the picture carefully, then we have, as m1 is greater than m2, it must be accelerating downwards, and here it must be accelerating upwards. If you plot a free body diagram for this, this is m1 whose weight is acting downwards m1g, tension T upwards and acceleration downwards. Hence the equation can be written as downward acceleration means m1g minus T equals to m1a. What is that, children? m1g minus T equals to m1a. That's it. Their values were not given, but only is given that the acceleration of the system is given as g by 8. We'll substitute the value of acceleration later. For the second case, if you observe, and again drop the free body diagram, m2g is downwards, tension T upwards, and it is accelerating upwards. Now the equation for this is written as T minus m2g is equals to m2a. Solving the two equations, this minus T and T gets cancelled, then you are left with this m1g minus m2g is equals to m1a plus m2a. Taking out g as common, we have m1 minus m2 by m1 plus m2 into g is the value of a. Here, a, if I took out common, it will be left over with m1 plus m2, which I brought it downwards. That's it, children. Well, so but given that the acceleration of the system a is given as, acceleration of the system is given as g by 8. So let us also substitute the value of a as g by 8, and let us see what happens. So m1 minus m2 by m1 plus m2 into g equals to a is given as g by 8. So g by 8. Solving the above, g and g gets cancelled. Let us take the LCM of the above two. Cross multiplication gives 8m1 minus 8m2 must be equals to m1 plus m2. Or bringing the m1 the other side, we have 8m1 minus m1 must be equals to, what is left over, children? m2 minus 8m2 brought the right side will become 8m2 plus 8m2. So this implies 7m1 must be equals to 9m2, or m1 by m2 is equals to 9 by 7. What is the value, children? The ratio of the two masses is found to be 9 by 7. Hence, m1 is to m2 is equals to 9 is to 7. Hence, option number B must be true. Okay. Well, moving to the next question. 35th. A block A of mass 7 kg is placed on a frictionless table. A thread tied to it passes over a frictionless pulley and carries a body B of mass 3 kg at the other end. The acceleration of the system is, you're asked to find out the acceleration of the system, and the value of g is given as 10 meter per second square. Children, clearly in the figure, if you observe, weight of the body B is acting downwards. Mass B is having mass 3, so 3g downwards, tension T upwards. Here if you observe, the mass of A is 7 kg, so 7g downwards and the normal reaction upwards. Clearly N is equals to 7g, they are balanced. But the tension in the string will be acting towards right side. So because of this tension, this A is being accelerated. Suppose in the system, if this is accelerated downwards, then this must be accelerated right side. And because this tension pulls the block towards right side, whereas the weight of the body is balanced by the normal reaction. So let us again consider the free body diagram and find out the acceleration of the system. So first of all, if you consider the first body, that is body A. Okay, case 1 for body A, if you consider, what is that? The tension acting in the system is nothing but mass of A. What is mass of A, children? 7 kg into acceleration. That's it. T is equals to mass of the body into A. Mass of the body is 7 kg. Acceleration be some A. Again, if you consider for body B, so this is the case. So for body B means, if you consider this, 3g is downwards, tension is upwards and acceleration downwards. So as it is downward motion, we have 3g minus t must be equals to 3a. Solving the above two equations, we get t and minus t gets cancelled. Hence, we have 3g must be equals to 10a, or a is equals to 3g by 10. But the value of g can be replaced with 10. So 3 into 10 upon 10. So these two 10s will get cancelled. Hence the value of acceleration A is found to be 3 meter per second square. Therefore, option number B must be true. Well, moving to the next question, 36th. Two masses M1 and M2 are attached to a string which passes over a frictionless smooth pulley. When mass M1 equals to 10 kg and mass M2 equals to 6 kg, the acceleration of the system is. So it's a normal Atwood machine numerical. So observing the same, clearly we have M1g must be acting downwards and M2g must be acting downwards. Tension in the string upwards and tension in the string upwards. Clearly we have 10 kg is greater than 6 kg. That means M1 is greater than M2. So here as it is, this mass is greater, it must be accelerating downwards and this must be accelerating upwards. So now let us also drop the free body diagram for this. Now this is the first case, and here say for M1, for first body M1, let us drop a free body diagram. So what is this, children? This is M1, weight M1g acting downwards and tension T acting upwards, but it is accelerating downwards. Tension T, M1g and acceleration downwards. Equation for this is written as M1g minus T equals to M1a. That's it. If you observe the second case, for the second case, that is for mass M2, if you write the free body diagram, M2g downwards, tension T upwards, whereas it is accelerating upwards. So when it is accelerating upwards, the equation of motion can be written as T minus M2g is equals to M2a. Let us solve the two equations. When you solve the two equations, it was observed that minus T and plus T gets cancelled. Hence, you are left with the, what is you are left with, children? M1 minus M2 into G equals to M1a plus M2a. M1 plus M2 into A. Okay. So here m1g minus m2g. Common is g. G is taken common, m1 minus m2. m1a plus m2a. A is common, taken out. Left over with m1 plus m2. Hence the value of a is found to be m1 minus m2 by m1 plus m2 into g. This is the relation for addition which we have already solved. Well, substituting the values of m1 and m2, we have m1 is taken as 10 kg, m2 is taken as 6 kg by 10 plus 6 into the value of g they haven't given. Let us assume it as some 10. Hence the value of acceleration will be, so what is this children? A is equals to 10 minus 6 is 4, 10 plus 6 is 16 into 10. So this 4 goes 4 times, 4 4 16. So 10 upon 4. So the value of 10 upon 4 is found to be 2.5 meter per second square. Hence the correct option must be option number C, that is 2.5 meter per second square. So option number C must be true, that is 2.5 meter per second square. Got it children? So directly, if you remember the formula for addition, directly take this as A equals to m1 minus m2 by m1 plus m2 into g. So if you are not aware of the formula, just simply approach the concept. Well,